Greetings, math friends. We are going to take a look at this fifth degree polynomial and see if we can factor it. So factors are things that multiply together to give you the original thing that you had. In this case, we want to factor this into a series of binomials where possible. And then the product of those should give us back the original polynomial. One of the places to start. So a lot of questions are, where do I start in a problem like this? Well, we want to look at the constant at the end. Finding factors of it to be able to use as factors of the polynomial is one of the first things to look at. If your polynomial has a non-1 lead coefficient, this one does not, but sometimes they do, you could look at the product of that lead and this last number, factors of that, or ratios of this last number with the lead coefficient as the denominator, and then you could find like factors that are fractions. All right, so we have 120 here, so there are lots of options to choose for that. I'm going to go ahead and go with 5, and I'm going to use a method of synthetic division. So for synthetic division, I take the coefficients that I have here and I list them. So I have 1, 6, 3, -6, -4, and -120. And I'm going to divide that by, this time I'm going to try 5. I don't know if that is a factor of this or not, but that's what I'm going to try. So when we synthetically divide, we add inside the bracket and we multiply around the outside. So 1 plus nothing is 1. 5 times 1 is 5. So I'm going to put that 5 up here. I'm adding in here again. So 11. 5 times 11 is 55. I'm adding again. So I have 58. And then I have 5 times 58. So that is 290. And then I'm adding in here again, but this is a negative number, so this is a positive and negative number together, so that magnitude's going to be smaller. Right now, I see that these numbers are getting pretty big, so it doesn't look like I'm going to end up with a 0 at the end. So this isn't going to work out for me. I'm going to go back now. I don't want to throw this away completely. We need to realize that whatever number that divides this, the negative of that number also will work. We know that this is negative, so a positive and a negative could multiply together to give us this. So I'm going to go back through, try this again, but with a -5. All right, restarting with -5, I have 1 plus nothing is 1. -5 times 1 is -5. This adds to 1. And we just go through this process again, adding in here and then multiplying here. So this last number here is going to be a positive. That's a good sign because we want these things to add up to 0. 5 times 4 is 20. 5 times 2 is 10. So that gives me what I need. So since I see this 0 here, we have found a factor. All right, so what does that mean for us? Well, that means that x is equal to this -5 that we put out here. So if we want a binomial out of this, we're going to add 5 to both sides on the equal sign here. So we have x plus 5 is equal to 0. And this left-hand side of this, the x plus 5, that is a factor of this. Now, we're not going to throw away the work that we've already done. These numbers here represent the depressed polynomial. They represent the coefficients of the original polynomial that are the quotient that is left when we divided this factor out. All right, so what I'm going to do is I'm just going to make another division bracket underneath here, looking at just these remaining 5 numbers here, and I'm going to try to divide my next number into here. Now, I divided out a 5 here. A 2, this is an even number, so I'm going to try either a 2 or a -2 and see what works there. So I'm just going to do +2 next. No real reason other than I like +2. So we're just doing this process again. I'm adding here, I'm multiplying here, and just going through this process. And we end up with another 0 here. So that means that x equals to 2 is a root. We bring this to the other side. X minus 2 equals 0. This is our next factor. So x plus 5 is a factor of this, and x minus 2 is a factor of this. And again, we still have this that we can work with. So we can try to divide by another number that will divide 120. So we had a negative that worked, we had a positive that worked. 3 divides this, so I'm going to go ahead and try a 3 and see if that works. If +3 doesn't work, I'm going to go back through and try a negative. So let's do +3 here. So 1 plus nothing is 1. 3 times 1 is 3. So then 18, this is going to get too big. So I'm going to go back through and try negative. All right, 1 plus nothing is 1. -3 times 1 is -3, so that's 0. This times this is 0. -3 times a +4 is -12, and again that gives me a 0. So x equals -3 is a root. Bring this over to the other side. X plus 3 is a factor. All right, now I have 3 numbers left. I'm going to change my strategy now because I know I have 2 more numbers I'm looking for because this is a 5th degree polynomial. The fundamental theorem of algebra says that I have 4 solutions, real or complex, that I'm looking for. I found 1, 2, 3 here, and I have 3 numbers left. I'm going to switch up and use Sridharacharya's formula. A lot of people know it just commonly as the quadratic formula. This is really the A, the B, and the C values that I would plug into the quadratic formula. So I'm going to switch up strategies here, and I'm going to use these values in the quadratic formula. All right, I've reset a little bit. I left my factors over here that I found already, and I've used the A, the B, and the C here to plug in Sridharacharya's formula. And now I'm just going to simplify this. The -0 on the outside goes to 0. Adding 0 doesn't change the magnitude. 0 squared in here. Again, another 0 that just doesn't change the magnitude. So I end up with a -16 in here. And then this is over 2. All right. In this situation, we end up with a complex result here because we're going to take the square root of a negative. We're going to end up with plus or minus 4i over 2, which reduces to plus minus 2i. So those are the last 2 that we need. So again, this is x is equal to this. That's how the formula works. So x is equal to 2i means that this is the factor x minus 2i. And then the other factor is x plus 2i. So those are my 5 factors. So we can say that this thing here is equal to x plus 5 times x minus 2 times x plus 3 times x minus 2i times x plus 2i. All right, so this fifth degree polynomial has these 5 factors. And if you go back through, you can check your work by multiplying these together to see if you get this as your product. All right, so this is the answer that we are looking for. These are the factors of this fifth degree polynomial. I hope this has been helpful in seeing what we're looking for when we factor a polynomial. The same techniques that we use for finding zeros if this had been a function and we were asked to find zeros of the function, we find those zeros and they're related to these roots because we just move things to the other side, and that's these factors here. Cheerful calculations.